So I'm Mike Aucott, and yes, I was a research scientist for many years for DEP, and I retired in 2012 and started working on climate issues on my own. And then last year, I was asked to come back to DEP on a part-time basis and work on climate things again. So I'm still at it. And anyway, so I'm going to try to start off with a global perspective on what we're dealing with. And I'll go on to talk about what I think we can do at the local and state level to influence what happens globally. So let me see if I can make this. Here we go. So yeah, so if, in my view, and I guess a lot of us share this view, if we don't deal with climate change, the other issues just become almost irrelevant. We have to deal with climate change, or we're going to leave a terrible situation for our descendants. And we've known about this issue for a long time. The impacts are becoming obvious, and it's actually getting worse. We're not on track to solve the problem soon, and more actions are needed. Unfortunately, while it's important to walk the walk if we're going to talk the talk, and so I don't mean to cast aspersions on local actions, but they're not going to be sufficient. We have to do things that work at the national and international level to avoid major impacts. First of all, the point that we've known about this for a long time, and the impacts are becoming obvious and it's getting worse. This woman, Eunice Foote, not really well known, was really the one who first discovered that carbon dioxide absorbs infrared radiation, and she made the prediction that if carbon dioxide increased, it would warm the Earth. She didn't get a lot of publicity in her day. Women weren't really admitted to the upper echelons of science, but nevertheless, her findings did become known, and they were picked up later by others and expanded on. One who expanded considerably was Svante Arrhenius, who got a Nobel Prize in chemistry, not for his work on climate, but he was asked in the 1890s what would happen if CO2 content of the atmosphere doubled. And he did some calculations and took into account the positive feedback that exists with water vapor, which is also a greenhouse gas, and concluded that if CO2 doubled, the Earth would warm about 4 degrees Celsius. And this is very close to what very sophisticated models today are telling us. And we've all experienced the greenhouse effect when we've gotten into a car on a sunny day. It's warmer inside the car than it is outside. And that's because energy from the sun goes through the glass. It's absorbed inside by the surfaces inside the car, and it's re-radiated as infrared, which does not escape through glass. So the energy stays in the car and warms it up. And something analogous happens with the Earth's atmosphere. Energy from the sun comes in, warms the Earth. That energy, much of it, is re-radiated. A lot of it as infrared energy, which does not get through the atmosphere as readily as visible light. And so it kind of bounces around and warms up the Earth. And we're adding to the greenhouse effect by adding greenhouse gases to the atmosphere. We're making the greenhouse effect stronger. Without the greenhouse effect, the Earth would be much colder than it is. So it's a natural phenomenon, but you know, the old adage, you can have too much of a good thing. We're adding to the greenhouse effect by adding greenhouse gases to the atmosphere. And CO2, which is the major greenhouse gas, in addition to water vapor, is building up in the atmosphere. And this buildup is human caused. And why do I say that? Well, first of all, it's clear that it's building up. This is perhaps this is often called the most famous chart in the world. And I don't know how famous charts ever are, but this one is considered to be very famous. This is the Keeling curve, and it shows the steady increase in atmospheric CO2 over the last 50, 60, 70 years. And we know that this is human caused. It comes from combustion. And the chemistry of that, of course, is very well known. The pace is unprecedented, the pace of the buildup. And when you look at longer term records, these are data from ice cores. We can now bore down into polar ice caps and extract the core of ice and look at the little tiny bubbles that are entrained in that ice and estimate what the greenhouse gas concentration of the air was at the time that those bubbles were entrained. And we can now go back 800,000 years or so and look at the CO2 content. And there's also various surrogate measures of temperature. And there's a close correlation. Perhaps the most important thing about this is the rapidity of the recent rise. If you look on geological timescales, the recent rise in CO2 is almost a vertical line. It's just an unprecedentedly fast increase in the greenhouse gas content of the atmosphere. And two other major greenhouse gases are building up, and these are also increasing rapidly. These are mostly from agriculture, and we're not going to get into that in this talk because CO2 is the main one, but these are important also. Methane and nitrous oxide are also building up rapidly. And the Earth is heating up as predicted. 2023 was the hottest year since record keeping began. The 9 years since 2015 are the warmest on record. This is a chart that was made in 1988 by the late climate scientist Stephen Schneider. And at that time, the observed data only went up to the early 80s. That's the dark dots here. And the climate modelers at the time made some projections based on what could be the greenhouse gas emissions, high emissions, low emissions, moderate level emissions. This is what they predicted the temperature would be, and here's where we are today. So this was nailed pretty well in the late 80s, and the predictions also say that it's going to get hotter. Major impacts are becoming obvious, and we've all started to see these. One of the most robust is sea level rise. This is sea level at Atlantic City. It fluctuates from year to year, but there's a steady increase that's significant. And we see that at a global level also. And the Jersey Shore, of course, is impacted by sea level rise. It makes the reach of a storm greater. We're seeing steady erosion of the beaches, and there's been a lot of that in the news lately. And there will be more, because when it comes to the battle between humans and the ocean, as one oceanographer once commented, if you make an analogy to the battle with the sea of a baseball game, the ocean always bats last. And so no matter how much sand we put on the beaches, it's going to keep eroding. It's very cost effective to replenish sand. The coastal communities are worth billions of dollars a year, but it's a battle that's just going to get more and more difficult. We're also seeing sunny day flooding. We can replenish the beaches, but the back bays are a different story, and we're seeing more and more so-called sunny day floods, high tides when there's no storm, but there's just an unusually high tide. And that's going to continue also. It's estimated that that will accelerate quite a bit. We're also seeing more intense rain events. The warming accentuates the hydrological cycle. Warm air holds more moisture. warm air also causes more evaporation from soils. So we're seeing not only more droughts, but more heavy precipitation, and that's very clearly happening, and especially in the Northeast. And we've seen some tragic floods. The one last year that washed some people away in Bucks County, and I think it's becoming hard to ignore that these things are happening. Of course, we had the smoky skies last summer. And there's starting to be some of that in the Northwest again this year. This is a chart put out by one of the major reinsurance companies. The reinsurance companies are companies that insure the insurers. And as you might expect, they're very concerned with catastrophic storms, and they've been increasing. The green here is, and this is costs and numbers of storms. That are numbers of severe events that have happened, and you can see that the trend is accelerating, and a lot of it is caused by severe storms. And the worst thing is if this wasn't bad enough, that the heating appears to be accelerating. The reason is that over the last 20 years or so, particularly since 2020, the International Maritime Organization has clamped down on the sulfur content of the fuel that is used for the world's container ships. And there's tens of thousands of these ships plying the seas, mostly in the North Atlantic and the North Pacific. And the fuel that they burn releases sulfur compounds into the atmosphere if the fuel contains sulfur, and those sulfur compounds become sulfates in the atmosphere, which are highly reflective, and they reflect the sun's energy. We've removed the sulfur, about 80% of it, from these ocean-going ships, and as a result, the skies over the North Atlantic and the North Pacific are much more clear than they were, and that allows more of the sun's energy to be absorbed by the dark surface of the ocean. And so we've seen an acceleration in global warming. Apparently, it's pretty clear that we have, and it's very likely due to the very sensible action of removing sulfur from the fuels. The sulfur is nasty when the ships are in port. There's plenty of reasons to remove particle pollution, but ironically, it's making the warming worse. And this is a picture that shows these plumes from ocean-going ships that are now have been lessened by quite a bit due to the removal of sulfur. Article in Science points to this. Cleaner air fueled the warming, and we can see that in records of the ocean's heat content. Most of the Earth's warming is registered in the oceans. The oceans have much higher heat capacity than the atmosphere, and we're seeing an acceleration in the warming of the oceans. So it shows that that's happening. And another measure, a different sort of measure, looking at the radiation that's absorbed and given off by the Earth, shows also this increasing warming trend. We're not on track to solve the problem soon enough. More actions are needed. And I say that because when you look at the data, and New Jersey has probably done as much as any state and maybe more than most. And I think the people at BPU and Mike WInka and those of you working on clean energy have had a lot to do with that. Nevertheless, we are really not on track to reach our goal. If you look at the recent trends, this reduction, this is total greenhouse gases emitted by the state of New Jersey. And we saw quite a drop in the early 2000s, but it's leveled off since then. This was the 2020 goal, and we've met that. But it's when we look at where we want to go, it's not looking like we're going to get there. This reduction here that gave people some hope really was caused by the change from coal to gas. If you look at the fuel mix of the PGM network of power stations, we see that over the period of time of concern, we've shifted from coal to gas, and gas is less carbon intensive, and so that's the reason for much of the reduction. But that's a one-off. We can't do that again. If we take out 2020, which was obviously an outlier of a year, and we look at the trend in New Jersey, it's hard to see that it's on track. This is the U.S. as a whole, also not really showing a strong downward trend. There are some promising initiatives. So and Mike and Steve and Pat are going to talk about some of that. And so this, we may see we may get back towards moving in the direction we want to be. And I'm happy to point to some of these things, the Energy Master Plan and this recent publication by the office that I'm now privileged to work with at DEP. The Inflation Reduction Act makes a lot of things possible that weren't before. So we may see some progress. And I'm optimistic, but I'm not overly optimistic because I think we're ignoring something. So what are we ignoring? Well, we're ignoring two things. One, globally, CO2 emissions are still increasing. And two, climate disruption is a global problem. If we cut New Jersey emissions to zero, we're not going to avoid the impacts. And at the global level, CO2 emissions actually increased the last year and probably this year as well. Why is that? It's because even though we've made progress in renewable energy, fossil fuels at a global level are still being burned at ever greater quantities. And we also have to acknowledge that New Jersey is a tiny part of the problem. This is humanity's greenhouse gas emissions last year, about 37 billion metric tons. The U.S. emissions is this orange square, and New Jersey barely shows. We're about 0.3% of global emissions. Most of the increase over the last few decades is from emerging economies. Mature economies have leveled off. Emerging economies are causing most of the recent rise in greenhouse gas emissions. Why is this? Well, they want electricity. And electricity is something that makes for a better life. I think we all know that. And when you look at the per capita electricity use in this country, it's about 1,500 watts per day on average per capita. Your own house probably uses 800 or so watts per hour, and globally, it's the continuous flow of power in the U.S. probably averages about 1,500 watts, because we have our residences using energy, but we also have the food market and the traffic lights and the industries that supply the products that we use, et cetera, et cetera. And so we use about 1,500 watts continuously on average. But if you look at much of the rest of the world, Africa, India, those people are only using 100 or 150 or 65 watts of power continually. It's just the equivalent of having a light bulb burning. That's how much energy they're using. And they need more if they're going to have a good life. You can't even have refrigeration with that kind of per capita electricity use. So the developing world wants electricity, and they're going to try to get it as best they can. And if they can't get it from clean sources, they'll get it by burning gas and coal. And that's what's happening increasingly. It's a power plant in India. So that's why I say local actions won't be sufficient. We have to do things that are going to translate to national and international measures. What might some of those things be? Well, let's recognize fossil fuels have a huge hidden subsidy. The waste product of their combustion is dumped into the air for free. And we could address this with a fee on carbon emissions. If this was done in a revenue neutral way, it wouldn't hurt low and moderate income people. And there are some bills before Congress that would do this. You would put a price on fossil fuels based on the carbon content that they have at the point where they enter the economy. You'd refund that to families. Yes, it would raise the price of fuels, but because the money would be refunded, people would be able to compensate for those increases. And actually, studies have shown that low and moderate income people, on average, come out ahead with this kind of a program. And there is a pricing bill before Congress now, and I'm happy to say that my Congresswoman, Bonnie Watson Coleman, is a co-sponsor of this bill, the Energy Innovation Carbon Dividend Act. It remains to be seen whether Congress will act on this. So far, they haven't, but these proposals are out there and they make sense. What about global action? The promising idea is the Prove It Act. And the Prove It Act basically would require the DOE to determine how much carbon was emitted in the process of manufacturing key commodities. And what we've seen over the last 25 years is that a lot of heavy industry has been outsourced. You look at manufacturing in general, ammonia manufacture, steel manufacture, cement manufacture, plastic manufacture. Developed economies are blue, emerging economies are tan. Emerging economies are taking a much bigger share of heavy industry, and much of this is powered by coal combustion. So they're not producing these things in a clean way. And the Prove It Act would quantify this. It would attempt to really clarify what is the carbon footprint of imports versus domestically produced goods. And it would put a fee on imports based on the difference between the carbon content of their manufacture and the carbon content of domestic manufacture of the same products. And this would actually help our industry because by and large, we think they're cleaner from a carbon standpoint, not in all cases, but in enough so that on average, it would help our industry. European Union is already in the process of doing just this, putting a fee on imports based on carbon content. So the Prove It Act would try to clarify those numbers, and we need good, solid numbers before something like this would work. Also, and this is the bill that I'm talking about, the Prove It Act, and this is bipartisan. Senator Kramer is a Republican, Coons a Democrat, and there's many other Republicans and Democrats on board with this concept. And it could set the stage for this carbon border adjustment, and this would push other countries to clean up their act. Also, I'm a believer that next generation nuclear can scale to the developing world if it can become cost effective. And we were once a leader in nuclear technology. We've kind of dropped the ball on that for a variety of reasons over the last 40, 50 years, but there's a lot of effort now to reestablish U.S. leadership in nuclear energy. And why is nuclear likely to help? Well, it checks a lot of the boxes. It's clean, it provides firm power, low land use, no need for much transmission build out, very good paying jobs, produces heat, which solar and wind do not, and we need heat for industrial applications. Heat will make it easier to produce hydrogen. The only issue with nuclear, it's not cost competitive. And there's hopes that that new technology will be cheaper. And the Senate has passed a bipartisan bill to try to streamline the NRC's approval process, which is a part of the big high cost of nuclear. They passed the Advance Act in July last year. Companion bill in the House, the Atomic Energy Advancement Act, passed by a huge margin this year in February. And just a few days ago, the House passed what's called the Fire Grants and Safety Act, which includes wording of the Advance Act. And this bill was introduced by a bipartisan group, Representatives Kane and Pascrell, New Jersey reps both, passed the House overwhelmingly. So we're familiar with Congress not doing much, but they've been doing some things in a very bipartisan way regarding nuclear. So there's some hope that we'll see advanced nuclear advancing, next generation nuclear becoming cost effective. So in summary, the need for action has been clear for a long time. Current efforts are not enough. More is needed. We can protect ourselves from the worst impacts of climate disruption only by fostering actions that will scale to the nation and the world. And I think that what can we do? We all need to become more involved, more informed, make climate-friendly choices. And you'll hear a lot more about that from our next speakers. Encourage people to vote for climate-friendly candidates, and join a group working for national and international solutions. And an example is the Citizens Climate Lobby, which I'm happy to be part of. And we're going to be in Washington again this June. This was in 2019, and I'm in this picture over here. You can see me. I'm a couple of pixels over here. So we meet with Congress, and it's actually surprisingly fun to meet with Congress people and their staff. And so I'm happy to try to answer any questions later. And here's my email. Don't hesitate to get in touch with me if we don't get to any of your questions tonight. And thanks a lot. I'm glad to be able to be part of this group. So that's it for me.
Thank you, Mike. My name is Steve Miller, and I wanted to just apologize to the people who joined us after we first started here. And I thank you for finding your way to our alternate Zoom link. This is the first time in 31 or so monthly building electrification webinars that we inadvertently had a collision of two different Zoom conferences, one webinar and one meeting tonight. And so we separated them to avoid dire results of colliding. I'm sorry this happened. We're going to be posting all the recording and the slides on the website with indices to all previous webinars. And we're keeping to a tight schedule. We're saving questions to the last, and we're prepared to really keep going to the last question. My wife will be handling Q&A, and she's collecting questions as we talk. And so if you have questions, put them into chat, and we'll pay attention to them. Thank you. The next speaker is Mike WInka, former director of New Jersey BPU Clean Energy Program. And with that, I will introduce Mike.
Thanks. So I'm going to share my screen. You guys can see that, right?
Yes.
Okay. And my introduction is I'm an energy nerd and energy policy wonk. So what I'm going to talk about today, mostly from the New Jersey Energy Master Plan. I'll go through some of the size of the issues in New Jersey, some of the mitigation strategies and the cost on a bigger, higher level. And then Pat and Steve will get down into the more local levels. I'll leave with 3 or 4 charts that sort of summarize why I think we're in an optimistic position to win this climate battle. So So the size of the energy system in the United States is about $2 trillion, hundreds of thousands of miles of pipelines and wires. It's about $44 billion in New Jersey, about 6% of our GDP. So a big part of the GDP. Climate issues is energy issues, and energy policy is climate policy. So in New Jersey, that's about 100 million metric tons of CO2 equivalents, about 11 metric tons per person. The average in the US is about 15 metric tons per person, so we're a little better than the US, about 5 metric tons per person. You heard Mike number one, I'll be Mike number two, talk about the global CO2 issues and where people are today. So we're twice the emissions on a per person basis than the rest of the world, but a lot better than most of the folks in the United States. And every state is different. The more coal and industry you have, the higher your average emissions are. In New Jersey, the three biggest sectors are transportation, using fossil fuels for transportation, heating our homes and businesses, and electric generation. It's about 80% of the total CO2 emissions. The two main fossil fuels are gasoline and natural gas. 84% of our greenhouse gas emissions come directly from burning fossil fuels for energy. So this is from the Energy Master Plan, and the reason why I'm talking about more of the Energy Master Plan, it's up for comments coming up over the next month, over the next couple of weeks, and over the next 2 months. Comment period, I think Pat and Steve can circulate the comment periods that are out there. I strongly suggest that, if you have comments about how to improve the Energy Master Plan, submit those comments. Folks do consider those comments. So New Jersey's current goal in the 2019 Energy Master Plan is 100% clean energy and an 80% reduction in our 2006 greenhouse gas levels by 2050. And 100% clean is defined by maximizing electricity in the transportation and building sectors powered by 100% carbon neutral electricity. So there are 23 states that have different types of 100% clean energy goals. They're listed here. You can go to this website, the Clean Energy States Alliance. About 53% of the US population has some sort of clean energy goal associated with them. And they're all different, but basically they're all the same. So basically there are 5 buckets that you can put your energy strategies in. It's reduce emissions from the transportation sector, accelerate renewables, accelerate and maintain the energy efficiency and peak demand reductions, reduce energy use from the building sectors, and decarbonize and modernize the grid. Those are things that, the strategies that go behind there, there's dozens of individual strategies that go behind each one of these buckets. But the key that we're realizing is we have to make that an integrated energy plan. We can't just talk about things in buckets, reducing the transportation emissions, because then folks say, oh, well, your fuel for your EVs is coming from fossil fuels. So the integrated plan says we're going to reduce our emissions from transportations with electric vehicles powered by clean, renewable electricity. You have to make that connection and keep making that connection across the board. We're going to reduce our emissions from buildings by electrifying the heating powered by clean, renewable energy, and we're going to advance clean, renewable energy to power our transportation and building sector. So that strategy has to be interconnected and integrated across the board. When you do that, you set your goals. This was the modeling that was done by Rocky Mountain Institute for the Energy Master Plan. It said if you have that goal, those endpoints, you can model the least cost scenarios to get you to that endpoint of 100% clean energy and 80% reduction in greenhouse gas emissions. And you can see the reductions in all of those types of fuels. I want to just talk about the difference between policies and strategies. So the Energy Master Plan is complete with a bunch of strategies to get you to that goal, but it's not a law. the policies that are in place are laws. Those are the regulations, the statutes, the codes that say you have to do these things. This is the number of solar that we want in New Jersey. This is the energy efficiency that we want. Those things are in statutes. And you can see this dotted line here is the impact of those policies in terms of greenhouse gas reductions and getting to the 100% clean goal. They're sort of listed here in this blue box. You can read them later. But you can see here that existing policy in the 2018 Clean Energy Act only takes us so far. About 2027, we start to get a divergence from the existing policies to our pathway down to 100% clean energy. But the good thing is everything in black on this chart were things that were in existing policies that the BPU used to model the 2019 Energy Master Plan. The things in red are the things that were new after the Energy Master Plan. So we're actually further on this policy chart down here, but we still need to do, upgrade those policies. So we're moving along, but we still can do better. So we're going to electrify both the building and transportation sectors. And most people go, we're going to double electricity and double my electricity bill. Well, yes. But if we meet those strategies, we actually reduce our energy use. We go from, this is the difference as being an energy wonk or an energy nerd, about primary energy and final useful energy. So electricity is a better final useful energy than the primary energies that we're using now. We go from 1.4 trillion BTUs down to 0.8 trillion BTUs. So a 40% reduction in our energy use because we're using less gas, natural gas, we're using less gasoline, but we are doubling our electricity. And then the comment comes in, well, the grid isn't going to be able to handle it. How much is it going to cost us to upgrade the grid? The current revenues generated by the all our customers' current use of electricity is about $11 billion. So we're going to double that to $22 billion just at the current rate. The current cost that I heard for upgrading the grid is about $4 billion. So we have $11 billion worth of revenues, additional revenues to cover a $4 billion cost. And in the BP world of rates, when your revenues exceed your cost, there's no rate impact. Just something to think about when people start saying, where are the costs and benefits? How much is it going to cost us to upgrade the grid? You have to have both sides of that equation when you discuss those things. And here's a little better chart about talking about those costs. If we upgrade the building and transportation sectors powered by renewable energy, this is part of that least cost modeling scenario. And again, they modeled the least cost. This is not zero cost. So everything below the line here is things you don't have to pay for in the future if we do electrify the transportation and building sectors. The things above the line, renewables, grid, cars, the incremental cost of new cars, because you're going to buy a car regardless, the incremental cost of appliances, they're going to pay for these things, but the cost that you actually will pay is the differential between these avoided costs and these costs that you have to pay. And that's a little better explained here. And these costs are all detailed in the Energy Master Plan in the technical appendix to the Energy Master Plan. You may hear some folks say, oh, the cost wasn't in there. Well, it was in here in detail. So this is a chart. If we do nothing, this is what the cost is to all of us, because we're going to buy cars. We're going to upgrade our heating system. We're going to pay for fuel along the way. So this is roughly what you would pay, about 3.5% of the total GDP over 30 years. If you do that to meet your emission goals, this is roughly what you pay. So it's that differential. It's about a 0.2% total increase in a 30-year GDP. So it is a cost, but you tell me whether that 0.2% is a relatively high or relatively low cost. And here's another way to look at this on the right-hand side. So if we go back here, that cost that I just showed you is the total avoided cost under this curve versus the cost above this curve. So it's the cost underneath that curve. That other chart that I'm going to show you is just if you take a slice anywhere along this, and talk about the incremental cost at that point in time, and that's what's here. This is the incremental cost in 2050. This is what you have to pay in 2050 if you have those goals and you want to reach those goals. This is that avoided cost. We're not paying for those fuels. We're not paying for combustion engine vehicles. We're not paying for natural gas heating systems. So that's the avoided incremental cost. The difference is about $2 billion in 2050. The other side of that equation is these are the annual benefits. The avoided cost, Mike said, whoops. Where am I? Okay, the avoided cost of greenhouse gas emissions, the avoided healthcare costs. And you can see that's about $4 billion to $6 billion worth of benefits. So the benefits are in the cost benefit ratio 2 to 3 to 1. Whenever you have a cost benefit ratio greater than 1, your analysis is cost effective. So in general, the Energy Master Plan, we can meet our greenhouse gas emissions. We can do that at a relatively low cost with 2 to 1 benefits. Existing policies won't get there, but this is the most important point. Even in that least cost system, it's going to be substantially different than the system we have today. And that's the sticking point in all of this. So when we talk about those strategies, and there's dozens of strategies in the Energy Master Plan, it really comes down to 6 strategies: energy efficiency and basically whole home weatherization, getting to keep the thermal energy inside the structures, building electrification, heat pumps, induction stoves, electric vehicle charging, on-site solar, community solar, on-site storage, both electric and thermal, community solar, community thermal systems, storage systems, and this thing called smart grid or grid interactive efficient buildings. I'll talk about that in a second. So just to take a little step back, it's important to have a state energy master plan. It's important to do a community energy master plan at the local level. BPU is providing funding. I think the grant program for community energy grants is open until sometime next week. You can apply and get $10,000 to put together a community energy plan. The good thing about it is Sustainable Jersey has guidelines on how to put it together, and they have a template on how to put together that plan. Plus, they give you all the municipal data that you need to put together that plan. So you don't have to spend money searching for data. It's all there. What they ask you to do is pick specific goals that you want to get to, and don't pick 12, 24 goals. They suggest pick a handful of goals, concentrate on those goals, measure those things, go out and talk about them, and then remeasure them and see where you are over time. That's how we're all going to get together to implement that reduction in greenhouse gas emissions. So to take this down one step lower in terms of cost and energy use, this is an average single family home, about 2,400 square feet, 2 cars, 25 miles per gallon each. This household uses about 1,000 gallons of gas, 1,000 therms, and 9,000 kilowatt hours, just about average. So it's spending around $6,000 per year on energy costs. And you can see it's driven by gasoline and then 50-50 by electric and natural gas. So again, if I electrify my home, I'm not paying for gasoline if I'm driving an EV. If I have a heat pump, I'm not paying for natural gas. So I'm going to double my electric use. I'm going to double that cost, but I'm actually saving $3,000. I'm not spending $3,000. I'm only spending $3,000 on my total electric bill if I electrify my system, because again, it's looking at primary energy versus final useful energy, which is a lot more efficient on the electric side. Same thing on the energy use. You go from 250 million BTUs, and a million BTUs is about 7 gallons of gasoline, down to about 80 million BTUs. And the same thing on the emissions, on the greenhouse gas. You can go to 0 emissions. Even if you're buying electricity off the grid, you're about 6 metric tons per year as opposed to 17 in this example. So just to make that connection between how things have to be integrated and connected together. So just 2 examples. Pat and Steve are going to go into some of this in a little more detail. So if you buy an electric vehicle, maybe you have an incremental cost of about $10,000. That electric vehicle is 4 times more energy efficient. It's 3 times less cost of fuel, 40% less cost to maintain over 10 years, even including the cost of the battery. But if you have the ability to put 3.5 kW of solar on your roof, typical solar system on an average use to fit that average house that we talked about is about 7 kW. So 3.5 kW will generate enough electricity over the year to fuel your vehicle to make it go for the entire year. Without an incentive, it's a simple payback period of 10 years. With all the incentives currently in the federal investment tax credit, it's less than a 5-year payback period. You're driving your EV on free fuel for 20 years, and you're getting 0 CO2 emissions by that situation. Same thing on heat pumps. And so here's an example for a heat pump water heater. It's 2 times more cost than a regular high efficiency gas water heater, but it's 3 times more efficient. But the issue with natural gas is because it is a lower cost. Natural gas operating cost for a high efficiency water heater is 3 times less costly. So 3 times more efficient, but 3 times more costly. Your operating cost match your efficiency, and your payback period is a long time. But the good thing is 1.5 kW of solar on your roof at $2 a watt may cost you about $3,000. The heat pump water heater, even with the 2 times cost, and the solar have a 9-year payback period. If you run your heat pump if you have your heat pump for 10 years, everything after 9 years is free, hot water, plus you get 0 CO2 emissions out of that. So that's the way you have to start thinking about how we put these things together. And this is just an example of that smart grid. Right now, when you turn on a light, the grid operator says, I'm turning on a generator, I'm going to send you an electron at the speed of light, your lights come on. What's going to happen in the future, that grid operator is going to call you and say, oh, by the way, I have some extra electrons. Do you need your EV to be charged? What about your storage system? Do you have some smart load you can run at this point in time? Or conversely, if you have solar on your roof, they're going to ask you, hey, I need a couple of your electrons to sell them to somebody down the street. You're going to have this 2-way conversation. It's all going to happen at the speed of light, and it's going to happen with the assistance of AI that moves all of these things around, basically a smart grid and a smart home. So that's the end of my sort of presentation. I'm going to leave you with these 3 graphs. If I still have some amount of time left. I'm out about 20 minutes. This is the policy for the Renewable Energy Portfolio Standard. It was put in place when we implemented deregulation of the energy market. You can buy electricity now from anybody, anywhere. The fear then was everybody was going to buy cheap coal and emissions were going to go up. So they put in place this policy, the Renewable Portfolio Standard, the RPS, and said that supplier has to have a certain amount of renewables in its portfolio when they sell it to you. It started at 0.25% in 2000. Each one of these lines you can see is the change in that policy over time. We doubled it in 2003 from 2% to 4%. We made it to, excuse me, we made it to 20% by 2020. And then the Clean Energy Act made it 50% by 2030. And that endpoint here, those red numbers, are if we stayed at that policy that was first implemented, that's what the RPS would have been in 2030. 10%, 13%, 36%. So you can see how policy builds on over time, and it happens in slow steps. So at some point you're yelling and screaming and saying, this isn't working, even though it's changing over time, because you asked for it, just like you can do in the Energy Master Plan that's coming up. You can ask for those changes that you need to happen over time. And they actually listen to implementing those things. This is another confusing little chart. I just want you to look at the red line, the gold line, and this blue squiggly line. The red line is the Global Warming Response Act that Mike talked about, to get to 1990, from 1990 levels back to 1990 by 2020, basically a 20% reduction in greenhouse gas emissions. The gold line is that 80% reduction in greenhouse gas emissions. That squiggly line is what Mike showed you, is the annual greenhouse gas emissions. And you can see we were significantly below the standard that they set in the Global Warming Response Act. And when they set that, the comments were, this is unreasonable. We'll never get there. Well, we got there with additional space. And they said the 2006 goal, the 80% reduction, will never do that. And you can see we're hovering around that standard. And these two dashed lines are just, if you want to improve that, if you want to make that happen faster, if you want to make that happen lower, you have to just go back and figure out, well, what are those things and the strategies that we need to push up in the policies that we want, and how much above what we're paying now do we want to spend? It's a real simple equation. In the next chart, this is why I'm convinced we will get to 100% clean energy well before 2050. Mike showed you this chart, Mike 1, about the generation profile in PJM. It's mostly dominated by fossil fuels. This is the capacity. It's not the energy generation, but you can see it's mostly natural gas, that blue bar, that, little circle there, coal, that little purple bar. But on the right-hand side, that's what's in line, waiting to be connected, the queue in the interconnection. You may have heard the problems that these facilities can't get interconnected fast enough. 150,000 megawatts of solar waiting in line, 55,000 megawatts of storage, and 44,000 megawatts of wind. Now, not all of this is going to get built, but you don't see coal on this list. You see a small amount of natural gas on this list. Most of that is going to happen. And then the problem is, people say, well, can the grid handle this? How is it going to happen? Another confusing chart that I want to leave you with. So this is the history of energy consumption in the United States from when the time we signed the Declaration of Independence in 1776 to about 2012. Just focus on this gold line, natural gas, and this petroleum line. The time frame between these two lines, these two blue lines, is 30 years. So you can see the growth in natural gas over that 30-year period of time and the growth in the oil industry in that 30-year period of time. If you look at those two charts of oil pipelines and natural gas pipelines, we built that infrastructure over that 30-year period of time. So people that say we can't upgrade the grid over the next 30 years haven't looked at this. This is the same chart that I just showed you. It's taken out to 2019, and you can see the curve now for renewables is beating the curve for coal. So there's more renewables being put in use in total consumption than there is for coal. And you can see this curve now mimics the curve for the growth in natural gas and the curve for petroleum over that same period of time. So if the past is a prediction of the future, that curve over the next 30 years will be built out just like we built out these energy infrastructures for natural gas and oil. And I'll leave you there. So I'm not sure if I made it under the 20 minutes, but and that's my contact information if you have any questions. If we don't get through them tonight, feel free to email me. So
Thank you,
I
Mike.
think
Well
we're
done.
good.
Yeah.
we have to stop sharing.
Reminder, we encourage you to write questions in chat. We'll also give you chances to talk during our Q&A period at the end. We'll hopefully have 15 minutes available. And we will have links to the recording and to all the slides by this Sunday evening, so you can look forward to that. Next up is my wife, Pat.
Okay. All right. Power your savings with electrification and the IRA. We're Pat and Steve Miller, as you well know, I believe, co-founders of the New Jersey 50 by 30 building electrification team. We're climate activists and retired engineers and managers at the former Bell Labs in Homedale. I'm going to give a quick overview of what we know as of now about the Inflation Reduction Act, the IRA, that was passed by Congress in 2022, and the incentives it gives for electrification of buildings and vehicles. Many of my slides are created by the Climate Reality Project, with a few from other sources such as Rewiring America, NRDC, the Natural Resources Defense Council, and a few of our own slides. Steve will then review the steps we personally have taken toward electrification of our own and our daughter's home and our church, and the money and emissions we're all saving in ongoing energy costs. The IRA allocates almost $370 billion, according to the official estimate, to climate solutions and energy security. But it comes largely in the form of tax credits that don't have a limit on how many of them can be activated. So many experts believe that the total funding from the IRA is going to be much, much larger than that. It just depends how many people can be motivated to take advantage of the tax credits for electrification. The total could turn out to be double or more. And this law, when combined with existing state and other policies, will enable the U.S. to sharply reduce global warming pollution by 40% or so below the 2005 levels. That's getting close to the commitments we made as part of the Paris Agreement, as well as both President Biden's and Governor Murphy's stated goals, which were 50% by 2035 and 50 by 30, respectively. The IRA's emission reduction measures are primarily those that consumers can address. They're almost exclusively voluntary with the help of incentives. The most important step for reducing building emissions is to replace gas or oil-fueled appliances, such as furnaces and water heaters, with much, much more efficient electric alternatives. And the heat pump versions of space and water heaters save you money and are 2 to 5 times more efficient than gas or oil. And it doesn't matter how cold the climate is where you live. People in Maine and Canada use cold climate heat pumps. They work just fine no matter what the temperature. Energy efficiency is the first step to take. Upgrading insulation, attic and walls, and even floors, air sealing and weather stripping, making sure windows are as airtight as possible. These are now benefits in the IRA that are available to help us do all these things. Plus, one of the most cost-effective things you can do is to install rooftop solar systems with battery storage. Lots of people are doing this, and the provisions of the new law make it much easier for everyone to do it. We can support community solar, which we have in New Jersey, where individual rooftop solar systems aren't really that viable. Say if you're living in an apartment, you can be part of a group using community solar. There are cost benefits to electrification. The electric appliances with heat pump technology or induction cooktops are much more efficient and so are much cheaper to operate. The energy efficiency measures reduce on average 25% of a household's overall energy use and thus save about 25% on energy costs. That's the efficiency measures. And that adds up to real money. Rooftop solar has a payback of 7 to 10 years and thereafter provides free energy. The rebates and tax credits in this law make all of these upgrades far more affordable. There are benefits where environmental justice is concerned. Home environments have been shown to be extremely important determinants of the health of the people who live in the homes. And low-income communities experience higher rates of asthma, especially among children, and are far more likely to suffer from the health impacts related to pollution and the exposure to extreme heat. IRA incentives make it affordable and especially benefit frontline communities by lowering their exposure to pollution, both inside and outside the homes, and to extreme heat. Space heating and cooling is the biggest emitter of greenhouse gas in buildings. Switch to an electric heat pump. Modern heat pumps are incredibly efficient. They reduce electricity use for heating to a fraction of electric resistance heating, like furnaces and baseboard heaters. Heat pumps both heat and cool. During our first year with a heat pump, we calculated we saved about 20% in total energy cost. The first step in making the switch in your home is to do a home energy audit. These are offered by our local utilities, both gas and electric, and also for a small cost from companies the state has accredited to provide the audits and contract for the work to weatherize the home. They will also make recommendations for which appliances to upgrade first and for the size of the unit you'll need. Just be wary. If anyone recommends simply replacing a gas appliance, I think this audience knows that, with a newer gas appliance, say no. We need to get off fossil fuels entirely. From now on, we should not be buying gas or oil appliances of any kind. Electrify everything. Electrify vehicles. When it comes to EVs, you see the same improvements. On average, the maintenance cost for a battery electric vehicle is 40% less than the maintenance cost for internal combustion engines. And of course, the cost of operation is much, much lower. You've heard a lot about gas stoves recently. Recent reports show a correlation between childhood asthma and gas stove pollution, which leaks not only methane into the room, but also pollutants like benzene, nitrogen oxides, carbon monoxide, and particulates like smoke. It's a serious problem, and the solution is to switch to an electric stove. Electric induction cooktops use heat in an unusual way. They use a magnetic current that is evenly distributed through the cooking pan, both bottom and sides. When you remove the pan, the cooktop is cooled to the touch. No wasted heat. These electric stovetops are better for cooking too. They boil water faster. They simmer more consistently. Now with the IRA incentives, it's time to make the switch. This is an easy to see graphic from NRDC of all the areas, both inside and outside the home, covered by IRA individual incentives. Number 1 at the top is rooftop solar. Number 2 is insulation and air sealing for energy efficiency. In the attic, at the bottom for the floor, and on the sides for the outside walls. Number 3 is windows and doors. Replacement in older homes is often not recommended because of the high cost, but new construction should have double or triple panes, and all windows and doors in old or new construction should be air sealed as much as possible. Number 4 is the EV and its charger. 5 and 6 are the heat pump, water heater, and dryer. 7 is induction stovetop. 8, smart thermostat. And 9 is the heat pump heating and cooling. The picture appears to focus solely on building electrification, but note it includes EVs and chargers and clean solar energy too. These are the 3 largest sources of greenhouse gas emissions, so the IRA covers them all. This chart was created by Dr. Leah Stokes, who works for Rewiring America. It lays out the 5 different IRA individual incentive programs. The first 2 lines, electrification and efficiency, are rebate programs, which are income limited. They will not go into effect until later in 2024 or early 2025, after your particular state has designed or upgraded its state programs to incorporate the federal IRA funding plus any state funding. The state programs are already in effect in New Jersey, and the IRA rebates go into effect on January 1st, 2025. The rebates will be in the form of a discount through the vendor at point of sale. The last three lines on this chart are tax credits. They're available to anyone who pays taxes, except for the EVs, which are only for LMI, low moderate income. They're available, the tax credits are available now for 2023 and onward. You would write off 2023 projects that you did last year when you file your 2023 taxes, which you probably have already done. And if you fail to claim a 2023 project that you did you did last year on your taxes, you can still file an amended return for 2023. The annual maximum amounts can be used year after year, so staging your upgrades over multiple years might make sense. We hope that as many people as possible take advantage of these tax credits as many times as they need to electrify everything and eliminate most or all emissions. The tax credits are also available to churches, even though churches are not required to file taxes. The IRS has created special forms for churches to claim the IRA tax credits. This slide shows the actual maximum amounts for the tax credit items that are available now. For example, there is up to $7,500 for new EVs. My daughter just used this at the end of last year and got the refund. And $4,000 for used EVs, EV chargers, heat pumps, and so on. You can get copies of the slides after the talk. We'll send them to you and see the exact amounts for all of these. This table gives the maximum amounts for many of the rebates that will be available from the IRA. The rebate programs, though, are administered by each state according to DOE guidelines. In New Jersey, the programs will not begin until January 2025, as I said. The program proposals for these rebates just came out from the BPU and are slated to cover only low income, less than 80% of the area median. And the bulk of that will go to renovate and electrify whole multifamily buildings, with a small amount targeted to single-family homes whose occupants are eligible for Comfort Partners program. The majority of folks across the U.S., but across New Jersey and probably in this audience, who are middle to upper income will do best to take advantage of the tax credits. Rewiring America has created a very handy tool for everyone's use that tells you which IRA rebates and tax credits you qualify for based on your zip code and income. Just go to the rewiringamerica.org site and you'll find it easily. Then have a home energy audit and make a plan for how you will electrify. Rewiring America can also help you with that. They have a new tool now for making a plan. Since appliances often break down when you least expect it, a plan for how you want to replace each one is helpful. A lot of appliances will likely need to be replaced in the next 8 years, which is all that's left of the IRA's lifetime, so be prepared. Keep in mind, Rewiring America's site may not yet be state-specific, so what you see may just be the original federal IRA design until our rebate programs get approved and go into effect. One last IRA reference. Steve has put together a handy table on 2 slides that he created of both federal and state New Jersey state incentives that are available now. On the left side are two of New Jersey's largest utilities, PSE&G and JCP&L, electric utilities both. Different utilities have different amounts. The numbers in red are amounts the utilities have proposed for 2025. They're just at the proposal stage, not yet accepted. We're in hearings to hear about these. On the right are the IRA tax credits and rebates, the maximum amounts. The last column for rebates is also just at the proposal stage. The federal and state amounts can all be stacked or added together, whatever you're available for. And this is the bottom of that slide with some helpful references. And again, I know you can't read this, so you'll have to wait for the slides. Now, Steve is going to talk about our own home projects and how much we and our church are saving. I'll go on to the next slide.
Thank you, Pat. For most of the last decade, Pat and I have been climate crusaders, and we're currently focused on energy-related sources of greenhouse gas emissions, which are the most predominant in New Jersey. And so tonight, I'm going to describe progress in electrifying you can go to the next. I'm going to show progress in electrifying cars, our house, and our church. And the topics include transportation, electrification, and our buildings you see here. And I will go through the steps we homeowners can complete and discuss the rebates or tax credits we might receive for the next decade. First of all, we're going to address our goal of clean electricity. Rooftop solar is the clear choice for most people. It's highly profitable, but not practical for us. We're in a forested area and trees overhang our roof. For years, we had a third-party supplier contract for 100% clean electricity in wind from Texas. But now, for the first time, all New Jersey people with electric meters can subscribe to the nearest of hundreds of New Jersey local community solar programs. In this, a developer builds a large commercial solar field, usually on a rooftop nearby, and sells shares of electricity to subscribers at usually a 20% discount below your local utility. And so we selected a solar project about 5 miles from our house. Our newest car is a plug-in hybrid EV. It was comparable in price to a regular hybrid, and we got a tax credit. Ours is a Prius Prime, which we charge in our regular household with our clean electricity. It goes 30 miles on a charge before switching automatically to the hybrid engine. And the next chart shows the type of car you buy has a tremendous impact on your greenhouse gas emissions. At the bottom shows an average U.S. car getting 24 or 25 miles per gallon. It emits 10,000 pounds of carbon per year. That's assuming you drive 12,000 miles. The second from the bottom shows that our old hybrid, which has a small battery, has averaged 37 miles per gallon for its life of 68,000, and it's about 60% of the normal car. But the third car above is the car we're most proud of. It's a plug-in hybrid Toyota Prius Prime. Has a much larger battery. We drive it around town normally. Last year, we completed a 3,000-mile trip to Florida. And even after that long trip, the average for our 53,000-mile lifetime is 156 miles per gallon. And that's the result of that is really a significant reduction in greenhouse gas, as you can see. We're down to maybe 1,500 pounds. The fourth car above belongs to our daughter, who bought a Tesla Model 3 in December. A major advantage is the cost of electricity is about 1/3 the cost of driving with gasoline. And she has a free subscription for a few months for fast charging using the current New Jersey grid, which means it's only about half green. And so you can see that's almost second from the top bar chart here. But when that free subscription expires, she's going to install a garage charger. And see, when she switches to plug in her EV into her house, which is served by electricity from a nearby community solar, the annual emissions drop almost completely. And the near zero emissions are also true for all other New Jersey residents within the next decade or so, when New Jersey develops its offshore wind and nears 100% clean electricity. Next up is buildings. The first priority is to arrange an home energy audit, take the recommended energy efficiency measures, and here I show added insulation. Once your house is fully weatherized, you can then select a downsize and cheaper heat pump system for your new efficient home. And you will be switching household appliances to electric whenever the old ones wear out. And if you stage it over the next 9 years, you can make most of IRA rebates and tax credits. Many of the projects are do-it-yourself. This is something simple. My air ducts in my basement and attic are exposed. And these are the inexpensive tools and components to install my own duct sealing and duct insulation. Next slide. The most important and carbon-intensive appliance is your furnace or boiler. We had a heat pump installed to replace a broken AC. That's the closest unit you see on the left. And we reused our existing 6-year-old 95% gas furnace on the right. It's used for backup at lowest temperatures. And we were able to cut most of our gas usage. You'll see that in a second. And then a year later, our gas-powered water heater sprung a leak. You can see in this photo. We replaced the gas with heat pump water heater shown here. I planned this in advance, so when I knew it was going to leak at some point, and just went out and got this from Home Depot. That eliminated most of our remaining use of natural gas, and we received a $750 rebate check from JCP&L. And we had a sub-panel installed, next slide, shown on the left, for future electric appliances, because our old panel on the right here had no more room for circuit breakers. The IRA could cover some of this work as well. And next slide is our home heat pump pool heater wired to the new sub-panel, which replaced an old gas-powered pool heater. Next slide, our new heat pump for space heating plus the heat pump water heater saved $264 annual combined gas and electric, comparing 2021 to 2023. More important for saving the world, in 2023, we eliminated 96% of our greenhouse gas emissions. That's phenomenal. Next slide. In our monthly building electrification webinar, we feature homeowners talking about all their energy savings. One month we featured our daughter's house. 2 years ago, they had a large master bedroom addition. You can see construction here. That contractor chose top-of-the-line Fujitsu mini split. You can see on the right. Since then, I've acted as contractor to weatherize the rest of their 60-year-old house under the Home Performance with Energy Star provisions, and I really recommend this. I selected an energy auditor, SEAL, who found major air leaks and other assorted problems, and then contracted with SEAL to do all the work shown here. After I received the report, I could have gone to other contractors. This is called homes under the IRA in 2025, by the way. Most of this is receiving IRA tax credits. And our final project in 2024 will be to replace the existing 7-year-old low-efficiency gas furnace in my daughter's house, so we can eliminate most of the remaining gas bill. And so when our daughter filed her 2023 federal tax return, she was very pleased with the rebates and tax credits. Next slide. In 2023, our church was recognized by Interfaith Power and Light with a second place in the nation and received $500 Energy Saving Award for its Cool Congregation Challenge. So last year, we're repeating this again. We entered our church in a national virtual tour to showcase our 20-year efficiency and electrification project. Next, we re-roofed and installed a large 37 kilowatt, 44 megawatt hour solar system seen here. I calculate that the large solar system over its 25-year life pays for itself, for the new roof, which we replaced, and for the 6 heat pumps installed to replace 6 old gas furnaces. On left are 3 of the new heat pump outdoor units. On the right are the two of the indoor components. It uses a gas furnace as backup, much to my chagrin. This bar chart shows total CO2 emissions in pounds per year, starting from 70 tons of CO2 emissions in 20 2003. I'm sorry, it's the leftmost bar. And the rightmost bar shows we're down to about 30,000 pounds. And we'll see your data in a second. And back then, years ago, we declared a green sanctuary, which motivated the congregation for the next 21 years to support continuous energy savings in actions. The red is carbon emissions from gas, dark blue is carbon emissions from generation of electricity, and green is the bottom. At the bottom is carbon sequestration by our surrounding 16-acre forests. And we note that our church is now net negative. It sequesters more greenhouse gas than it emits when we include that sequestration. Next, the final table shows a 71% reduction in total gas and electric bill and a 76% reduction in greenhouse gas. And we are very proud of what we accomplished, but we still have more to do. Next, I should just mention this. I invite you to join our next webinar. We always do case studies, and the registration will be the same link you see here to a working Zoom, I hope. I think based on 30 months of experience, it will be. It will be 7 p.m. Thursday, June 20th, so I invite you. The next slide. We need everybody to speak up, act, and vote like your world depends on it, because your world does depend on it. So
Okay,
we are
I'm gonna
entering Q&A.
stop the share.
Yes, stop the share. We're always looking for people to talk about their houses. And I think the people who are on the show actually really enjoy volunteering and doing the work. You can see the smiles in their face. They find it worthwhile. And my wife and I have been monitoring chat to see what questions are coming up. We invite you to ask additional questions either via chat or type up and talk. I think you can all enable your own microphone. So Pat, what have you found?
Well, we were planning to finish this by 8:30, and then we realized that our talks were going to go over that. So we can go as long as it takes to answer the questions. I don't think there's a huge number, but we didn't want to do it during the talks because we thought if anything created controversy, it would take too long. So the first one, I remember Ken asked this question during Mike Aucott's talk, and he wants to know, is there a limit to the amount of heat the oceans can absorb?
Well, I mean, eventually, if you carry it to a ridiculous extreme, it would boil. You know, there's no feasible limit in our, to my understanding, in that makes any kind of sense as far as human life is concerned. I mean, it's going to be a function. It's going to be a function of how much heat keeps getting put into it. And right now we see that the upper ocean is a lot warmer than the lower ocean, and there's a very slow circulation. And so I think it could get a lot warmer, as could the atmosphere.
Which would be deadly for the life that's living in it.
Already causing problems with coral, and probably maybe something of more concern really with the ocean is the change in pH. The pH of the ocean is dropping, and as that happens, and that's because it's absorbing carbon dioxide, which becomes carbonic acid. And there's an equilibrium between carbonic acid and bicarbonate and carbonate compounds in the ocean. But as it becomes more acidic, the availability of carbonate decreases significantly, and a lot of marine creatures need carbonate to make their shells, and they're exoskeletons. And we've seen the ocean pH drop from about 8.2 to around 8.1, along with the rise in carbon dioxide content of the atmosphere. And that's about a 30% increase in the concentration of hydrogen ions. So it's quite significant. And if it keeps up, it will put a lot of marine creatures in trouble.
This is a comment rather than a question. Ken says financial gains are unlikely to solve the problem. I assume he's talking about a carbon fee of some sort, because they allow continued burning of fossil fuels. We need to move to clean energy solutions much faster.
No argument that we need to move to clean energy solutions. The carbon price idea would incentivize clean energy, and it would make fossil fuels more expensive, and it would offset their hidden subsidy. So I guess I think it would make a difference if it was widely adopted.
Yeah. Well, I've heard the statement that it would make all of the other measures that we're taking to clean energy, it would hasten them.
Right. I would agree. I would agree with that. There's a very interesting app. It's actually a model that people can use. It's called En-ROADS, and it's available online. It's a global model, but it allows you to look at all the various mitigation options that are out there, from planting trees to electrifying transportation, et cetera, et cetera, et cetera. And putting a price on carbon augments all of them, really, and it's the single most effective action. But as Mike WInka said, we have to think holistically here and move on all fronts.
One of the things, any subsidy is good to help move any of those clean energy technologies along. But one of the things to keep in mind economically now, the reason you're seeing these big lines, not only because of the incentives for solar and offshore wind and storage, is because they're economic now. If you go and look at the levelized cost of electricity, which is something DOE does, the Energy Information Agency does an annual report that says, what's the capital cost of these technologies? What's the operating cost? What's the maintenance cost? What's the fuel cost? Solar, even without, and wind, even without a subsidy, is the lowest cost way to make electricity. So it's economic. It's going to win. That's part of why, as I said, you see all of this sitting in line, and that line has to go through only if we upgrade the grid to allow more of that to go through. So subsidies help. I don't think anybody's going to turn away subsidies, but economically, you're across the threshold of these technologies, and that's across the globe. I mean, it's not only low cost here, but it's low cost in India. It's low cost in those countries that Mike talked about. The difference is the cost of money, right? So you can get the cost of money here in the United States at 5%, maybe now a little more, that they increase the prime rates. But in those developing countries, because of the risk, the cost of money is 20, 25, 30%. So that's the differential. The technologies are all the same. It's being able to put in place the financial mechanisms to be able to get there, to be able to do that.
I can jump for a
we're
second.
winning. I just think, when it all comes due. So anyway.
If I could just jump in for a second. I agree with Mike. And I think that targeted programs like the
Mike,
Which one?
I agree with Mike too.
And I think targeted programs like the IRA, rebates and things are, the most effective way to go in terms of getting consumers off their asses. But the other things, and I mentioned it in a comment, was we're actually paying billions in fossil fuel subsidies. And actually, if you look at the actual cost of fossil fuels, when you take into account the hidden costs, like the healthcare costs, we're paying trillions. And if we took that all away from the fossil fuel industry, if we made them pay for the full cost of what they're doing to our health and to our climate, and we stopped subsidizing them directly, it would make much more sense to me to do that than have a carbon tax, because
I think we'd all love to do that.
To be fair,
Ken, you have another.
eliminate all subsidies for energy across the board, and let's compete. Let's see who wins. So anyway.
Well, I would argue we should give subsidies to clean fuels, because we don't have the time to let this be, a normal replacement process. We got to do it in the next 20 years, and anything we can do, put in free heat pumps if that's what it takes, in order to, because with all of the feedback loops that we have, things are going to get worse faster and faster and faster, and so we've got to solve it in the next 25 years.
Yeah. Well, Ken, your next comment is
I don't have comments. I don't pay any. I don't spend my time.
Nuclear is very dirty when you consider the entire nuclear cycle. That's a comment rather than a question. But Mike A., you had something to say about nuclear waste, I think.
Yeah,
the last time we gave this talk.
I think that's a pretty outmoded idea, with all due respect, Ken. The nuclear waste, if that's what you're referring to, there's very little generated, and what is generated is it really amounts to a few kilograms per person per lifetime. So it's a small volume, and right now it's stored on site for a number of few years underwater, and then it's moved to dry casks. And those are stored on site with no problem. They're designed to last 100 years, and they'll need to be repackaged if we don't find a permanent repository. But nuclear waste, after about 600 years, virtually all the radiation is gone, and what's left is still toxic, but only if you eat it. These are alpha emitters that remain after 600 years primarily, and it's not the problem that it's been cracked up to be. It's more of a political problem than a technical problem.
So all the nuclear waste. First of all, I didn't say nuclear waste. I said nuclear is very dirty when you take into account the entire life cycle, including the mining and transportation and the processing and everything else that goes on. And you don't have that with clean energy.
That's your view. I would defend your right to have an opinion, but I don't think you're correct about that. Nuclear uranium mining has been improved dramatically recently, and we could probably continue this maybe.
Yeah, the whole industry, if you're going to do EVs, you're going to mine some lithium. You might be able to get that from coal instead of burning coal. They have rare earth elements, but the whole industry, the energy industry, is dependent on mining wherever you go. The good thing about it is, electric vehicles and all of this stuff that we're doing is all metal based. It's not burning once and we're done with fossil fuels. Lithium ion batteries are metal and can be recycled just like lead acid batteries. So they're starting to do that process. But Mike A. is, correct in terms of, the issues around nuclear are not, I agree more with Mike A. than Ken, but my opposition to nuclear is more on the scale. It's the systems that people are used to building. Goldman Sachs wants to build large, big systems. They don't want to finance the little system that, Pat and Steve put on their church because there's no money in it. They want to finance these bigger systems. That's where all these tax subsidies get in place. But you don't need those big systems anymore. The communication that happens between distributive energy now on your house compared to the grid is an order of magnitude better than it was and will be better in terms of being able to move those electrons around. So your house can actually operate just like a power plant in the future, or those small community solar projects can operate. That's my, talk about this stuff, is stay away from the big power plants as opposed to, building it more distributive. But
you made the solar at any scale is cheaper than nuclear.
Not necessarily. I think both of you guys should look at the latest LCOE stuff from Lazard. One of the issues with renewables is their intermittency, and we need a certain amount of firm power. Now, how much we need, it's not really clear, but even if you look at the Energy Master Plan, they talk about a certain amount of firm capacity. And a certain amount of firm capacity actually augments renewables. It makes renewables more feasible. So
again, if you look at the levelized cost of electricity, it's megawatt hours, right? It's not capacity. It's what's the next megawatt. So it includes that intermittency. And you can also look at the levelized cost of avoided costs, which DOE does in terms of the capacity factor. So you can get into that whole debate of intermittency, but the ability for us to measure wind resources versus solar resources and match those up are pretty good. So you don't need that, a lot of that firm capacity can be built by just managing the resources across the board.
Well, yeah,
I wouldn't throw away,
is,
if a nuclear power plant has to be built to be firm capacity, I wouldn't throw it away and say we shouldn't do it. But there are better ways to do that. And the bottom line is all of these things work. What doesn't work is fossil fuels. I think we can all agree on. We need to get away from fossil fuels. Any of these solutions that we're talking about work, however you put them together and however you package them, they all work. For me, I think we're going to build a whole lot of solar and wind before we build a nuclear power plant. But hey, that still works. It's better than burning fossil fuels and getting us into the problem that Mike A talked about. So
and I think we have to remember that a lot of the issue involves the developing world and what is going to work for the mega cities, the Cairos and the Jakartas and so on. And I think that small nuclear might come along and might become cost effective, and it might fit in very well with all of this. Time will tell. Time will tell.
Well, let's go on to, there's several comments here about the EMP. The EMP is being revised and updated as we speak. The first hearing is this coming Monday at 9:30.
Yep.
So if you want to have input into it, there for the next couple of weeks, they'll be having several hearings on the EMP. So that's going on, and I'm not going to debate whether it's worked or not. I think we're looking forward to the update.
One adder that they have experts brought in for the hearing, so that you're going to hear from the experts of what the EMP is and what it might be, and then they'll open it up for input. Conversation with Andrew Zwicker, Senator from New Jersey, and I volunteered some help for his introduction of the beneficial electricity bill that hopefully will be in 2 or 3 months from now. And it's possible to take case studies of electrification and play them up with and stuff that we're doing and stuff other people are doing, play them up on video or television and ads and printed media as well, all sorts of social media, and get more of public demand for the beneficial electricity. So that's one thing that I really am aggressively looking is to feature electrification case studies because we have an ulterior motive here. It's to help legislation in New Jersey. Diets. The chief speaker there was how to live longer by improving your diet.
Yeah, he
And
follows a vegan diet and writes about it. And Senator Zwicker was the person who introduced him to the audience and told the audience that his whole staff is vegetarian. So I thought that was interesting. All right,
So
back
on
to the
the EMP,
subject.
just to your, go and give the folks that are going to be sitting there your opinion. They do listen. And the EMP is 5 years old. That goal that says 100% clean energy with carbon neutral, that's 5 years old. Go tell them what you want. Go tell them, the building electrification 5 years ago was nowhere. I mean, the cost studies that were out there were slim to none. That technology is gone, guns a-blazing. So go back to, one of the hearings. There's three, I think, four coming up. So attend one of them and tell them what you think. Here's what we should do. Here's how to move this faster down the line. And I can tell you they'll listen and incorporate your comments into the changes in the EMP that have to happen. So
The next question is community solar. Is it available to all? As contrasted to only low income. The way the law is written now, it has to be 51% at least low income. And we're not sure whether they're holding them back until they hit the 51% for real, or whether that's a fuzzy target. We're not really sure, but we had kind of complained because we signed up for community solar. So our daughter's not low income either. They signed up for community solar in South Brunswick, where they live. We signed up in Monmouth County, Tinton Falls, where we live, and they got. I think they got service sooner than we did, but we had to wait 10 months after we were told it was going to go into service before it finally went into service. We don't know what the holdup was, whether it was just getting the approvals from the electric company to interconnect or what, but it did finally happen. So we now, both of us have our community solar. So it's available to anyone as long as it's not oversubscribed.
and the 51% is not a fuzzy goal. It's in the law. So they have to
I know it's
comply
in the
with
law,
it.
but can they go online without it, or
No.
no?
They have to have the
Okay.
commitments in place. That's probably why they have to have the subscription in place to show the 51% in the balance.
Yeah,
And
someone
there's
had
some, back and
suggested
forth,
that.
because it's not going to be actual 100%, and it's a good thing. That's, everybody, we want to rise all boats, right? So
I wanted to make a comment that we were aware. Actually, when community solar was introduced, I was helping, trying to sell it, make LMI folks aware of it, and it was really a really hard problem to get hold of people. I talked to my township administrator and said, "Oh, that's easy. They know who are LMI, and they just would write letters. We should have just asked him in our town." And I assume the same is true of the other towns. So now I know the solution. Get the town involved, and they will bring up the LMI people.
They would.
the solution is to get BPU to do more, open up, the community solar program. So they do fund grid supply solar. So just make all of those grid supply projects community solar projects. So you want to get money from the state, your project has to be a community solar project, not a grid supply project. The only people that benefit from grid supply are the developers that build, you know, and then, you know, you get some electricity that offsets fossil fuel. Just go and comment in the EMP and say, we want more community solar, and we want, you know, here's the number that we want. So
Yeah, but they put caps on them, right? You can't have one that's bigger than what, 5 megawatts, and aren't there limits?
but yeah, there's a size limit on the individual project, but there's not a size limit. You could put 10 5-megawatt projects, or you can have 100 5-megawatt projects, right? So, and the 5 megawatts is, you know, to get some distribution of capacity across the state. You don't want somebody putting up 100 megawatts in one location. So 5 megawatts is like 25 acres of capacity. So
Okay, we're actually to the end of the questions.
All right.
And unless someone has another question, and let's make it a question, not a comment. Well, thank you all for coming. This was very enjoyable for me. It was more enjoyable because we've done the talks before, and it was a little easier this time. But thank you
Remember,
so much.
we're looking for
you have great
volunteers.
projects there. That's, you know,
We're looking for volunteers. If you've completed an electrification plan, if you in the middle of one, or if you want to be electrification plan, let us know. We'd like to involve what we can do to help you with your electrification plan
Yeah.
and maybe feature you. So that's
And you know,
it.
Steve,
Yeah.
if we want to go afield from just the building electrification case studies, Mike A had mentioned that En-ROADS tool, and we
Yes.
know someone, Susan Golden, who lectures about En-ROADS and gives demonstrations. So she would probably love to do a talk on it if we asked her to do that. So if we have a slow month, we could think of that.
So thank you all for joining us. I'm sorry for the interruptions. We only got about a half turnout, but that's okay. And I will see you next June 20th.